Hello everyone and welcome to a second episode of Math Past Year Papers on ZNotes Live. I'm your host Yukan, I'm here with Devandhira, and today we'll be continuing our IGCSE Admaths with our Paper 2 Variant 2 from this year's May-June. If you guys haven't seen our previous episode where we do Paper 1, you can check that out later. On to you, Devan.
Okay, so there's a couple. So thank you, Yukan. And yes, as Yukan said, my name's Devan, and I'll be the expert for this series. We'll be solving math past papers from Cambridge, from IGCSE to A Levels. And so in this episode, we'll be doing Additional Maths Paper 2, Variant 2, May-June 2020. So let's start. So of course, the first page will be the formula sheet. It's the same as before, nothing special. So let's head for the first question. Variables x and y are such that y is equal to sin x plus e to the power of minus x. Use differentiation to find the approximate change in y as x increases from pi over 4 to pi over 4 plus h, where h is small. So here's the thing. In these kinds of questions, when you need to find approximate change, the formula is the approximate change in y, you have to use approximation sign here, is the gradient multiplied by the change in x. Is that correct, Yukan?
Mm-hmm.
All right. So from here, we can see the change in x is basically just h, right? It's just the h, because from pi over 4 plus h, the difference between pi over 4 plus h and pi over 4 is just h itself. Is that correct, Yukan?
Yeah.
All right. So we have our first information that change of x is just h. Now we have to find dy dx. So let's differentiate our equation. Dy dx is equal to cosine of x. Remember that the derivative of sine x is cosine x.
Mm-hmm.
And the derivative of e to the minus x is just minus e to the minus x. By the chain rule, the derivative of negative x is just negative 1. And so it says that x increases from pi over 4. That means we have to evaluate dy dx when x is at pi over 4. Right here. So you can put this in your calculator, but I already know the value for this. It's 1 over root 2 minus e to the minus pi over 4. You just have to put x as pi over 4 here and here. You agree?
Mm-hmm.
All right.
Yeah, that's right.
So let's plug that in. We have the change in y. It's approximately, and let's put the value in. So as you can see, I just have to put this one right here. And then the change in x, which is h. And you can put this in your calculator and get the decimal. Can you put that in your calculator, Yukan?
Yeah, if you put pi over 4, you'll get 0.251 approximately.
0.251 h. All right, so that's your answer. So don't forget to box your answer. Is everything clear?
Yeah, and to the viewers, make sure when you're dealing with trigonometry to change your calculator to radians or degrees depending on what they give you.
Exactly.
So right now it's pi over 4, so that's a sign you have to use radians.
Exactly, that's correct. Don't forget to change your calculator mode, okay? All right, so next question. Do not use a calculator in this question. Okay, put down your calculator.
All right.
The point 1 minus root 5, comma p, lies on the curve of this expression right here. Find the exact value of p, simplifying your answer. They're challenging us not to use calculator, but it's okay. We got this. So here, let's think about the question first. It says that this point right here, this point, lies within the curve of this equation. That means if you draw a curve, that this point has to be like somewhere here, maybe. Is that correct? Like maybe here or here. That means if I put x as 1 minus root 5, the y will be p. Agree?
Correct.
All right. That means you just have to plug it in. P is equal to 10 plus 2 root 5 over 1 minus root 5. Sorry, Make sure to copy everything correctly. So everything so far, okay?
Yep, that's okay.
All right. So let's simplify this. I think we can start off by the square here at the bottom. Let's do that. So I'll put it in another line. 1 minus root 5 squared. So let's do this mentally. We have a squared minus 2ab plus b squared. We have 1 minus 2 root 5. Is it 1 minus 2 root 5? Yep.
Yep.
Then plus 5, because negative root 5 squared is just 5. The negative becomes positive, and the root 5, and not
Just
not
cancels.
the root. Yeah, the root got cancelled. Okay, we can just simplify a bit more. Okay, we have 6 minus 2 root 5. Not a bad thing. So from here, I think I can simplify this a bit more by dividing 2 in numerator and denominator. So 5 plus root 5 over 3 minus root 5. This will make things easier. But if you don't want to do this, it's completely your choice. It's okay. Right, Yukan?
That's
All
fine.
right. So where do we go from here? What's the next step?
Now you have to, because your denominator is irrational, you have to multiply by its conjugate.
Exactly. So we have to multiply the numerator and the denominator by the denominator's conjugate. If you don't know what the conjugate is, let's say you have a number like a plus root b. Its conjugate will be a minus root b. Is that correct? So in this case, our conjugate will be 3 plus root 5 over 3 plus root 5. Right?
Yep.
All right. So what is so good about the conjugate? Why do we have to do this? What do you think is the reason?
When we multiply a conjugate, we will multiply a sum by its conjugate, we would get the difference of two squares.
Exactly.
So that would cancel any roots.
Exactly. So as from before, from just normal IGCSE maths, if we have a multiplication like this, we would just get right. And this is the same case that's happening right here. As you can see at the denominator, we have 3 squared minus root 5 squared. So what's root 3 squared? That's 9. That's 9. And minus root 5 squared. That's just 5. What about the numerator? Is it the difference of square?
No. Those are just two sums you have to evaluate.
Of course not. So we have to do this manually. But before that, let me just write this first. Root 5. Let's simplify this a bit more. We have the denominator as 4. Let's open this up mentally. 5 times 3, that's 15. 5 plus 5 root 5. So we have 5 root 5 and 3 root 5. That results in 8 root 5. I'll just make the line longer. Then root 5 times root 5, that's just 5. Okay, we have simplified this a bit more. Are we done yet?
We can divide everything by 4.
Exactly. So as you can see that we can just divide this by 4, 20 becomes 5, and 8 becomes 2. We have 5 plus 2 root 5. Are we done?
Yep, we're done.
Exactly. Okay. Don't forget to box your answer. So the answer is 5 plus 2 root 5. Okay, next question. The third question. Find the values of k. Sorry. I'm sorry about that. Find the values of k for which the line y is equal to x minus 3 intersects the curve. Oh my god, that's so long. This expression at 2 distinct points. So what can you realize about this question? About this expression, especially.
That's a quadratic expression.
Exactly. So that's a quadratic expression, and this is just a linear, right? This one. Okay. So in these kinds of question where you're given a linear function, a linear line, it is a line, and a quadratic function, that's a hint that you should use the discriminant, correct?
Yep.
So let's remember what the discriminant is. People like to write discriminant as a triangle. I don't know why. But basically it says that In the quadratic equation, let me write it down. X squared plus bx plus c is equal to 0. The discriminant will always be b squared minus 4ac. What does the discriminant tell you?
It tells us how many roots there are
Exactly.
for a quadratic.
So, say your discriminant is greater than 0. That means there are 2 roots, correct? Is that correct, Yukan?
Yep, that's correct.
Okay. So when it's exactly 0, there's only 1. That's the ugly one. When it's less than 0 or negative, there's none at all. There's no roots.
Yep.
Okay. Hopefully you agree with that. So now let's solve this. We need to find the values of k for which the line, these two guys intersect at 2 distinct points. What does that mean?
So that means our b squared minus 4ac has to be more than 0.
Exactly. So let's do that. If we want to find where they meet, that means we have to do simultaneous equation. We can equate them together because their y's are isolated. So x minus 3 is equal to k squared kx. K squared x squared plus 5kx plus 1. Okay. Move everything to one side. We have 0. And I'm just going to simplify everything. Move this here. We'll have plus 5k minus 1x. So you see that the positive becomes negative here. Don't forget about that. Then 1 plus 3, that is 4. Okay. From here, this is the moment where you should use the discriminant. And because we want it to meet at 2 distinct points, that means we have to make it greater than 0. Agree, Yugan?
Yep.
Okay. So let's do that. So this is our A, this is our B, and this is our C. We have 5k minus 1 square minus 4k square. Sorry, this takes quite a while. Greater than 0. Okay, so let's simplify this. Let's do this in our head. 5k square, square of 5k, that's 25k square, minus 2ab, which is minus 10k, plus 1.
Yep.
Negative 4 times 4, that's negative 16. Negative 16k squared, greater than 0. Agree so far?
Yep, that's fine.
Okay. Let me just reduce the size of this first. Taking up space. Okay. So from here, we can simplify this a bit more. 25 minus 16, that's 9 squared. And everything is just the same. How can we solve this, Yugan? We're told to find the values of k. But how can we solve
So now
this?
you have to find the critical values. So that's the root of that quadratic.
Which is?
You can actually factor it to be x minus 1 and 9x minus 1.
K minus 1 and 9k.
Oh, kk, of course.
9k, sorry?
9k minus 1.
9k minus 1. Okay, greater than 0.
Of course, you guys can just use your calculator to find the values and then reverse from there.
Yep, exactly. You can do that. So here's the thing. Now that you've factorized it, we can at least just make a small sketch of the graph. Let me just try to draw the graph here. Okay. So the roots are at 1 and 1 by 9, correct? When k is 1 and k is 1 by 9. So let me draw that first. 1 by 9 and 1. That means the graph has to look like this. Oh my god, I'm so bad at drawing. I'm sorry. Okay, whatever.
Yeah, that's fine.
Yeah, I'm sorry. Okay, so here the point is, when is this function right here? When is this function greater than 0 from the graph? So as you can
it's
see,
anything.
yeah,
sorry. No, you were gonna explain.
Oh, okay, sure. So as you can see here, we want to find where the line is greater than 0, which means positive. And there are only 2 parts, which is this and this. Correct? This part and this part, basically. That means the function is positive It occurs only when k is greater than 1 and k is less than 1 by 9.
Yep, that is correct.
Yep. And are we done?
Yeah, that's all.
Okay. Because we're told to only find the values of k. And we found it.
hmm
Okay. Anything else you want to add here?
Some people might be a bit confused as to why we got ranges. They just asked for the values of k. If they asked for distinct values of k, that means you're supposed to find when k equals to something. But in this case, we're supposed to get ranges, yeah.
Exactly. That's correct. And also, the discriminant only works for quadratic functions. Only when it's x squared.
Yeah.
Once it's x cubed, sorry, you're out. All right. So next question. The three roots of p of x is equal to 0, where px is 2x squared, 2x cubed plus ax squared plus bx plus c, are x is equal to 1 by 2, and minus n, where a, b, c, and n are integers. The y-intercept of the graph y is equal to px is 4. Find the px, simplifying your coefficients. Okay, we can do that. It might look scary. So the first thing that I realize is the y-intercept of the graph is 4. What does that mean? How do you find the y-intercept?
So that is when it intersects the y-axis, and that's when x is 0.
Exactly. So that means when we put p of 0, where the x is 0, basically,
Mm-hmm.
these three guys gets cancelled because they have x's in it, and we're left with just c. Oh wait, sorry, c. Now they said that the y-intercept is 4. That means c is 4. Agree? So
Yeah.
we're done. Okay, we're done with the c. Very simple. Now we still have to look for a and b though. And okay, we can do that. Okay. So they said that the roots of the function are 1 by 2, n, and minus n. Correct? That means we technically can factor this function as x minus half, x minus n, and x plus n. This has to be equal to 2x cubed plus ax squared plus bx plus c, which is 4. Correct? But here's the thing. The coefficient of x cubed is 2. That means we have to multiply by 2 here. Why? Because if you don't, we have x times x times x, which is just an x cubed. It has no 2 in it.
Yeah.
All right. We can simplify this a bit more. I guess we can put the 2 in here. We have 2x minus 1. Okay. So let's expand this out. I'll expand the difference of squares here. We have x squared minus n squared is equal to that thing again. Then let's expand this one. So we have 2x cubed. 2x cubed. Let's see what else. X 2n squared x minus x squared plus n squared.
Yep.
I'll put this here so it looks easier. And I'll rearrange this part. Let me just switch the part to. Oh god. Oh god. Just 2n squared.
Pop up.
Oh, sorry. Okay. So what now? What do we do now?
Now we can compare coefficients.
Exactly. So the easiest one would be x squared, right? The a here.
Oh, yeah.
Because the a here has just -1. That means a is -1. What about our b? How do we find
We don't
b?
know what n is yet. So it's just 2n squared.
-2n squared. Don't forget about the negative.
Oh, yeah. -2n squared.
Yep. But can we find n squared?
Yep. That is
How?
just the constant, which is 4.
Exactly. So right here, as you can see, we have n squared and the constant here, 4. They don't have any x's, so they have to be the same. That means our n squared is equal to 4. Correct?
Correct?
Now that we know n squared, we can just put this in, and we would have minus 2 times 4, which is negative 8. Therefore, our polynomial is just 2x cubed minus x squared minus 8x plus 4. Agree?
Yep,
Do
that's
we
it.
have to find what the value of n is?
No. They never
No,
asked for n.
exactly. So you don't have to find the value of n, but if you want to, then it's just 2n minus 2. If you're jobless enough, sure. All right. So don't forget to box your answers, and we can move on to the next question. Coordinate geometry. Okay. The points A and B are 4, 3, and 12, minus 7 respectively. Find the equation of the line L, the perpendicular bisector of the line AB. Okay.
Hmm.
So what does perpendicular bisector mean?
It means the perpendicular bisector is a line that intersects the midpoint of the line, and it is at a 90-degree angle to it.
Exactly. So let's say you have a line segment like this. You have to find, that means you have to look for the midpoint first, correct?
Mm-hmm.
Then there has to be a line that intersects it through the midpoint. Let me just draw there. And it has to make a 90-degree. That is perpendicular bisector. All right. So how can we, let's see. The points A and B are these. So what's the first thing we have to find, Yugan?
We can find the midpoint.
Okay. So let's find the midpoint. Midpoint. So how do we find the midpoint here?
You add the x and divide by 2 and the y and divide by 2.
Exactly. So right here, our two x coordinates are just 4 and 12, so we have to add them. This is basically taking the average, right? So as you can see, this is just taking the average of between those two coordinates. And let's simplify this. We have 4 plus 12, 16 divided by 2, that is 8. 3 minus 7, what's 3 minus 7? Negative 4. Negative 4 divided by 2 is negative 2. Okay, so we found the midpoint. What's next? What's after the midpoint?
Now we have to find the gradient of the line.
Let me, sorry. Okay, so the gradient of the line, right?
Mm-hmm.
So the gradient, let's write gradient here. Gradient of the line. How do we find the gradient of the line again?
That's the change in y divided by the change in x.
Exactly. So let's do it. We have negative 7 from here, then minus 3. Because we want to find the change, so we have to take the difference. Divide by 12 minus 4. Okay. Negative 7 minus 3, that's negative 10. 12 minus 4, that's 8. We have negative 5 over 4.
Mm-hmm.
So what do we do with the gradient?
We know that for any two perpendicular lines, their product is negative 1. So we can use that formula.
Exactly. So for those of you who don't remember about it, if two gradients are perpendicular to each other, let's call it M1 and M2, their product will always be negative 1. So in this case, let's say our M1 is negative 5 over 4. That means this is our perpendicular gradient. We can solve for that, and our gradient would be 4 over 5. Correct?
Yep.
All right. So we have the gradient, we have the midpoint. Now we just have to find the equation of the line, right?
Mm-hmm.
All right. So let's do that. So we'll use the formula y is equal to m for the gradient, x minus x1 plus y1. What's x1 and y1?
That is the point it intersects. We know it intersects the midpoint, so we can just use that.
Exactly. So let's write that down. Y is equal to the gradient. Don't forget it's 4 over 5. Multiplied by x minus 8, because it's the midpoint, minus 2. And this is our answer?
No, we can simplify it.
Yeah, we can simplify this. Let me put it here. I can't do it in my head. So we have 4 over 5x minus 8 times. Can you calculate this?
8. What is 8 times 4? This is so embarrassing.
32.
32.
Negative 32 minus 2.
32 divided by 5. So you can minus by 10. That's 22 over 5. Hey, no, you're adding, so that's 42 over 5.
Okay, so it's negative 42 over 5. Okay, so this is your answer. And don't forget to box it.
Can
Everything
you
okay so far?
multiply both sides by 5 to give 5y is...
Yeah, that's also fine. That's also fine.
Alright,
You
cool.
can do that too. But if you want to do it this way, actually, you can also give your answer as this. That doesn't matter.
Oh, yeah, you can.
All right, but
Anything in that form.
yep, exactly. So if you want to simplify it or you want to leave it this way, that's completely fine. All right, next question. The line parallel to AB, which passes through the point 512, intersects L at the point C. Find the coordinates of C. The line parallel to AB. What does parallel mean again?
That means they have the same gradient. They never intersect.
Exactly. C. The line parallel to AB. That means, so at first we found what the gradient of AB, which is negative 5 over 4, correct? This one right here.
Uh-huh.
So the gradient of AB, let's just write it down again. Gradient of AB is negative 5 over 4. Passes through the point 512, intersects at L. All right, so what's L? Do you
L
remember
is
what L is?
our line, yeah.
Our perpendicular bisector, correct?
Mm-hmm.
Okay, so the line parallel to AB passes through the point 512. Let's write that down again. Negative 5 over 4. The equation of the line. X minus 5 plus 12, correct?
Yep.
Through this formula again, same thing. And intersects at L. That means we have to simultaneous equation here. 4 over 5 x. Oh, sorry. X minus 42 over 5. Okay. So far, so good?
Mm-hmm.
We can do simultaneous equation here. I think I'll multiply both. I want to make both equations easier first. Multiply the first equation by 4, so we have 4y is equal to negative 5x plus 25 plus 12. That's plus 37. This one too. 5y
Oh, yeah, it's plus.
x minus 42.
Mm-hmm.
Right? Is everything okay so far?
Yep.
Okay. And though you can use any method if you want. You can use elimination, you can use substitution. That's up to you. What do you want to go with?
We can multiply both equations by 5 and 4 respectively, and then equate them to
Exactly.
eliminate y.
Exactly. So we have multiply the first by 5, second by 4, correct?
Mm-hmm. They'll both be 20y.
Sorry, okay. 20y, 20y. Multiply by 4. That means we have negative 5.
The first one is by 5.
Yep.
Okay.
37 times 5. I can't calculate that.
That's 185.
Sorry for the pop-up. 185. What about the second one? 4 times 4.
4,
16.
16. Then 42 times 4 is 168.
Oh, 168. Okay. 168. Then we can just equate them together, right?
Yep.
Negative 20x, 25x plus 185 is 16x minus 168. Okay. So we can do this normally now. Let's bring the 25 to the other side and this one to the other side too. I can't calculate this one. Can you calculate that for me?
168 plus 185 is 353.
41x. Sorry, 3, 5,
3.
3, 5, 3. 16 plus 25 is 41. Is that right? Can you confirm?
653 does not divide 41.
Oh, wait. 353 or 653?
It's 353.
Oh, but 25 plus 16, is that 41?
25,
Plus
25
16.
plus 16. Yeah, that's 41.
Okay, so we have x as. Did we do our calculations correctly?
This is the fifth question, yeah?
Oh. Wait, let me. Yeah, this is the fifth question.
Okay, yeah, that's not right.
Oh, it's not right. I think we made a mistake
353
somewhere.
divided by 41.
Oh, okay. I think we made a mistake somewhere then.
N times 4. Oh, when we multiply by, for the first one, it should say 148, not 185. That's
Oh,
my
sorry.
bad.
Oh, okay. 148. No problem, no problem. Then we can equate them together again.
Yeah, the second one is correct.
Okay. Okay. Simplify everything
So
again.
148 and 168 is 316.
316. And
Okay, wait, this does not divide.
well, what's wrong?
They don't divide.
Where did we go wrong?
I'm not sure. Could you?
Let me check again.
Okay, no, 185 is correct, but that's not.
Did we go wrong in the first one?
Okay, no, the first
No.
one is right.
Oh, okay.
Hmm.
Wait a minute. Oh, it's this part here. This one. I made a mistake here. My bad. Okay.
What is that supposed to be?
I multiplied by 4. That means this has to be 48.
Ah.
Yeah, my bad. That was my bad. 25 plus
Okay,
48. That's 73.
48.
There you go.
Yeah.
Yeah.
So 73.
Times 5.
73 times 5. That's 365.
1 year. Okay, then we just have to equate them together again. Sorry about that, guys. Okay. Let's do it again. 41x.
Yeah, this does divide.
365
That's 533.
Can we divide that now?
Yeah, this divides into 13.
Okay. So we've got our x. Don't forget we have to find our y too, correct?
Mm-hmm.
So how can we find our y? We can just use either of the equations here actually, right?
Yeah, we can just put that back.
So what's the y? Can you calculate it for me?
So I'll take the first equation, 4
Mhm.
over 5 times 13 minus 42 over 5. So if we calculate that, it'll give us 2.
Okay, 2. And that's our answer. Sorry about the mistake, and that's an easy format. Thank you. Next question. Find the equation of the tangent curve 2y is equal to tan 2x plus 7 at the point where x is pi by 8. Give your answer in this form, where ABC are integers. Sure. So to find out the tangent, we first need to find the derivative, correct? dy dx.
Mm-hmm.
And to do that, let's make y the subject first. Y is equal to half tangent 2x plus 7 over 2. Before that, let's try to find the coordinate first. Because if we want a tangent, we need to find the coordinate, correct? The coordinate where the line has to pass through. That means we have to let x become pi over 8, correct?
Yep.
So when x is pi over 8, what's our y?
Then tan is pi over 4.
Mm-hmm.
That is just 1.
1.
So we have half plus 7 over 2, which is 4.
4. Okay. So this is the coordinate that it has to pass through. Now let's find the dy dx. dy dx is equal to. So let's recall that the derivative of tangent is always secant square x. But because there's a 2x, we have to multiply 2, because derivative of 2x is just 2. The half will cancel here. We have secant squared 2x. And the constant just dies when you differentiate. Okay. So let's find the gradient. We have to evaluate when x is pi over 8. We have secant square of pi over 4. 2 divided by 8 is just 4. It's just 1 over 4, sorry. What's this?
So pi over 4. So that's 1 over cos pi over 4 all squared.
2? Is it 2?
Yeah, should be 2.
Okay, it's 2. All right. Let's use the formula from before again for the line. Y is equal to m, which is 2 right now, x minus pi over 8 plus 4. Let's simplify this. This is not in the form that they want, so we have to simplify this. Y is equal to 2x minus pi over 4 plus 4. And let's bring the 2x here. We have 2x, sorry, 1 minus y minus 2x is minus pi over 4 plus 4. But are we done from here?
Yeah, that's in the form they wanted, right?
Are you sure?
Oh no, they wanted negative y, so we have to multiply by
Negative,
a
right?
negative number.
Exactly. So we just have to multiply negative, and we have 2x.
Could you give me a second, Devan?
Oh, sorry. Okay. All right. Well, Yukan has to be right back. It's okay. Let's move on. This is the answer, and don't forget to box it. Next one. This tangent intersects x-axis at P and the y-axis at Q. Find the length of PQ. All right. This tangent intersects the x-axis at P. Where is P? It doesn't say P. And the y-axis at Q. Oh, sure. This shouldn't be so hard. Remember that when it intersects the x-axis, you're still muted, by the way, Yukan.
Yep.
When it intersects the x-axis, y is equal to 0, right, Yukan?
Mm-hmm.
So let's find out when. That means P is when y is 0.
Mm-hmm.
We just have to put 0 here. And we have 2x is equal to pi over 4 minus 4. Just divide everything by 2 and you get an answer. That's 2. Now what about Q? Q is when, because it's at the y-axis, that means x is equal to 0. Correct?
Mm-hmm.
So we have negative y is equal to pi over 4 minus 4. And let's find the y. 4 minus pi over 4. Okay. Agree so far? Everything okay?
Yep, that's fine.
All right. All right. So let's write it in terms of coordinates. We have pi over 8 minus 2, 0, and 0, 4 minus pi over 4. So how can we find the length here? The length of PQ.
So if we draw a line, we can find that the change in y and the change in x gives us a right angle triangle. So we can use the Pythagorean formula.
Exactly.
Yeah.
So if we were to draw P and Q, so P and then Q here, you'll make this line right here, right? We can just use a Pythagorean formula. Oh, sorry. So we can find it. Just have to do this. Pi over 8 minus 2 squared plus 4 minus pi over 4 squared. All rooted. I mean, can you use calculator on this?
Yeah. So the square is this, and the root is 3.59.
3.59. Okay, so that's the answer. And don't forget to box it. Everything okay here so far?
Yep, that's all fine.
Okay. So let's move on to the next question, integration. Okay. I like integration. So let's do the first question here. The integral from 0 to 4 of 10 over 5x plus 2 dx. So remember that the derivative of ln of ax plus b is always a over ax plus b. That means if you integrate it, if you're to integrate this, you'll get the function itself, the ln itself.
Hmm.
So it's the same thing for here, for this one. But you see our a right here is just 5, right?
Yep.
That means we have to make our numerator as 5. But how can you do that?
10 is just 5 times 2, so you can factor 2 out.
Exactly. So we have 2 times 0, 4, 0 to 4 of 5 over 5x plus 2 dx. Sorry about the notifications. And that is equal to, of course, as I said before, we can integrate this directly. It results in ln of 5x plus 2. You have to divide it from 0 to 4, of course. Correct?
Mm-hmm.
All right. So let's do that. Let's put x as 4, and we have ln of 5 times 4 plus 2, which is 22, minus ln of, when x is 0, we're left with just ln of 2. And in result, remember that when in logarithms, when two logarithms are added, they multiply, but if they're subtracted, then they divide, correct?
Mm-hmm.
All right, so ln of 22 divided by 2, which is just 11, correct?
Oh, yeah.
Is this the final answer?
That, yeah, in its
Okay.
simplest form. You
Then
can
what's your
also
answer?
do ln 22.
Oh,
No,
sorry?
not 22. Ln 11 square.
Yeah,
But this is also fine.
yep, this is also fine. Okay, so let's go for the next question. The integral of 0 to ln 2 of e to the power of 4x plus 2 squared dx. This one's really easy. As you can see from the exponentiation, when you power it, you just have to multiply the exponent, right?
Mm-hmm.
0 to ln 2 of e to the power of 8x plus 4 dx, because you multiply by 2, correct?
Yep.
Okay. And how can we integrate an e again? So by the chain rule again, we'll get the derivative of the top. You have to divide it, which is just 8, because derivative of 8x plus 4 is just 8, correct?
Mm-hmm.
Then we have e to the 8x plus 4, evaluated when 0 and ln 2. Okay, so let's do that. 1 over 8 e to the power 8 ln 2 plus 4 minus 1 over 8 e to the power of 8 times 0 plus 4, which is just 4. From here, I would personally factor out 1 over 8 and e power 4. So if 1 over 8 e power 4 multiplied by e to the power of 8 ln of 2 minus 1.
Mm.
Is that correct? How can we simplify
Yep.
this?
You can raise 2 to the 8th power and cancel the e and ln.
Exactly. So we have ln of 2 to the power of 8. The e and the ln will cancel. So we're left with what's inside the ln, correct?
Mm-hmm.
Is this our final answer after we simplify this?
You'll get 255.
255. So we have 255 over 8 e to the power 4.
Yeah.
Can we use this as our final answer?
Yep.
Okay, so let's box it. There you go. That's easy.
Could you
5
check
and 4
the
marks. Sorry?
StreamYard chat, David?
No, I'll check it out later. All right.
Okay then.
So let's move on to the next one. Solve 3 cot square x minus 14 cosecant of x minus 2 is equal to 0. These two are different. How can we solve this? What do you think?
It gives us cosec, so you can just use the cot square identity.
Exactly. So if you don't remember what the identity is, we can always go back to the formula sheet. It's down there. Okay, right here. So as you can see right here, we can just use this identity, correct?
Mm-hmm.
All right. So sorry. So let's use that. But if you're lazy to remember, you can always remember this, what do you call it, this identity, where the most basic identity you should know actually, and divide both sides by sine square. You get 1 plus cos square divided by sine square. That is cot square x, and 1 minus 1 over sine square. That is cos x squared. Is that right, Yugan?
Mm-hmm.
All right, then we can just transfer it here. We'll have minus 1. Everything okay so far?
Yep.
All right. So now we know what cot square is in terms of cos x square. We can just plug it in. So we have 3 times cos x square of x minus 1 minus 14 cosec of x minus 2 is equal to 0. So let's simplify this out and expand minus 14 cosec of x. You have minus 3 minus 2, which is minus 5. Agree?
Mm-hmm.
And from here, what should we do? What do you think?
We can factor this. If you guys want, you can say u is cosec and then rewrite it. But you can straight away factor it into cosec minus 5 and 3 cosec plus 1.
So we have cosec x minus 5, right?
Mm-hmm.
And
3 cosec x plus 1.
cosec x plus 1. Okay, sure, we can do that. And now we're already like this, we can just equate each bracket to 0. So we have cosec x minus 5, but let's put it the other side. So it becomes is equal to 5. Then 3 cosec x is equal to negative 1, correct? Let's make cosec the subject. So I'll just do it instantly here. We have negative 1 over 3. Can we solve this instantly?
No, we have to find sine.
Sine. So what should we do to find sine?
You have to inverse both sides.
Exactly. So you have sine of x is equal to 1 by 5. Well, and this one, sine of x, is negative 3. Is that correct?
Yep.
Sorry. Now, from here, I think negative 3 would be rejected, correct? Because sine of x cannot reach negative 3. It can only go from negative 1 to 1. So we automatically reject this one. And we're left to only solve with this. All right. This should be easy, right? Just have to... That means x is just sine inverse of 1 over 5. This is our final answer.
Yep. Let me find the values. Oh, it's still on radian.
Oh.
So they asked for degrees.
Yep.
So we have to do inverse 0.2, which is 11.5.
11.5 degrees.
Yeah, and what's the range? 0 to 360. So we know there's two values in that range. 180
Exactly.
minus this, you would get 168.5.
168.5. Okay.
All right, pop
nice
up
one,
there.
Yugan. Oh, sorry about that. Nice one, Yugan. So we have two values of x, and that's our final answer. Oh, sorry. Don't forget to box it. So everything okay here? Okay, that's good. Next one. Show that sine power 4y minus cos power 4y over cot y is this expression, tan y minus cos y sine y. Okay. What's the first step here? What do you think we should do?
Ooh, we have the difference of two squares in the numerator, so we can factor that.
Exactly. So it's a power 4. That means if we unsquare it, we just get a square, right? We have sine square y plus cosine square y times sine square minus cos square y. All over cot y. Nothing changed at the bottom here. So as you can see, this one cancels to 1, right? From the identity.
Mm.
That means we're left with sine square y minus cosine square y. And I want to simplify this cot y a bit.
Mm.
Simplify the cot y a bit. When cot y is at the bottom, it just becomes tan y, correct?
Yep.
When you put it back up, it just becomes tangent of y.
Yeah.
Now, the thing is, we're almost ready to expand this, but if we expand this, we don't have a sine square y here, right? Is that correct?
Ooh, yeah.
Yeah, so what should we do? What's the trick here?
So we can change tan y into sine over cos.
Let's do that. Let's try doing that. Sine y over cos y. Sine square y minus cos square y. But even if we do this, we'll have a sine cube y. Right?
Oh yeah, that multiplies.
So that means that's not the correct way.
Okay.
What do you
So we can change sine square to 1 minus cos square.
Exactly, that's the trick. So we have 1 minus cos square, because there are two negative cos squares, so we have 2 cos square y. This is the time where you should multiply. So we have tangent of y minus 2 tangent y cosine square y. Okay, let's put it here. So are we done yet?
No, that's not the form they gave.
So what's next?
We can change again tan y into sine over cos and cancel the cos.
Sine y over cosine y. Sorry, cosine y, cosine square y. That means the cosine y here and the 2 will cancel, become 1, right?
Mm-hmm.
And I'll just erase this to make things simpler. We have sine y and cosine y. Are we done?
Yeah, that's it.
Okay, so this is your final answer then. And right, shown. Because they told us to show, so shown. Alright. Anything else you want to add here, Yukan?
No, that's fine.
Okay.
Everything's fine here.
Alright, solve the equation. This is an exponential equation. So, as you can see here, we have 9 and 27 as the base. My first instinct is to make them as base 3. What do you think, Yukan? Would you do that too?
Yeah.
Alright, so we have 3 square. 9 is just 3 square. 5x all over 3 cubed x minus 2. 2, 4, 3. Okay. What's next?
So you can expand them because when it's a power raised to a power, you can just multiply.
Exactly. So I have 2 times 5x, which is 10x, all over 3 to power of 3 times x minus 2. 3x minus 6 is 243. Now, since they both have the same base here, by exponential rules, if they divide, it's just subtracting the powers, right?
Mm-hmm.
Right, well, let's do that. So we have 3 to the power of 10x minus 3x minus 6 is 243. Let's simplify this a bit. So if 10x minus 3 is just 7x plus 6, 243. What's next? What should we do from here?
So from here, you have to check if you can raise 3 to the power of any number and it'll give 243. So by trial and error, that's 5.
Okay, so that means 243 is just the same as 3 power of 5, right?
Yep.
Or an alternative way, you would use logarithm, log base 3. That
if
should
your
work too.
computer has that, but not everyone's calculator has the log to the custom base power.
Yeah.
So if you don't have that, you can do something like this.
Okay, so that's a good one too. So because they have the same base, that means their exponent has to be the same, correct? 7x plus 6 has to be equal to 5 for the equation to be true. Now we can just solve this. So let's bring 6 to the other side. 7x is negative 1. X is negative 1 over 7. Is this our answer?
Yep, that's it.
All right. I will box the answer. Don't forget. And that's it, 3 marks. Next
Mm.
one. Okay, so for this expression, we have to solve the equation for b, giving your answer in terms of a. Sure, we can do that. So what the first thing I realize is that this part here is bothering because the b is at the base. I want the b to be the
Mm.
input instead of the base. So, but first, let's simplify things a bit, like this one. Remember that square root is the power of half, right? The
Mm-hmm.
power of 1 by 2. And logarithms, logarithm of anything, let's say x, y to the power of, let's say, a, the power can go to the coefficient. So a log of x of y, correct?
Mm.
All right, so let's use that rule. We have half log a of b minus half is equal to log b of a. Now, like I said before, this part here is, oh, sorry, this part here is bothering me. Why? Because the base is b and not a.
Mm.
It would be much better if it's a. But there is one rule that can save us from this burden, which is that log of x of y is the same as 1 over log y of x. So you just switch the bases, but you also have to reciprocate it.
Mm.
All right. So we can use that rule. And let me just copy everything again. A of b minus half is 1 over log a of b. Is everything okay so far?
Yep.
All right. We can multiply log a of b both sides. We have half log a of b squared. Don't forget the square there. Log. Sorry, this takes a while. And how can we solve this?
Well, writing log AB takes a while, so you can bring the 1 to the other side and then let
Mhm.
u as log AB.
So let u as log ab. So we have a half u squared minus half u minus 1. Correct?
Mm-hmm. Yeah.
So what now?
We can multiply everything by 2, and
Mm-hmm.
then I don't think we can factor.
We multiply
Oh no,
by
we
2
can, we
here,
can.
and we have 2 here. Just make things efficient. So what
Then
can you
we
factor
have
this into?
u minus 2
Minus 2 and
and u plus 1.
u plus 1 is equal to 0. Okay,
Mm.
you just have to equate them. U is equal to 2 and u is equal to negative 1. But don't
Mm-hmm.
forget what u is. U is simply just log of a, log base a of b is equal to 2, and same for the other one. And we just have to solve this. How can we solve this?
So we can raise both sides to the a to the power of. You wrote
So,
2 twice, Devan. It's negative 1 for the second one.
sorry. My bad. My bad. All right. So we make both sides as the power of a, right?
Mm.
Okay. That means the log a in the left-hand side will cancel, leaving b, well, a squared. Same thing for the other one, a minus 1.
Mm.
So is this our final answer?
Yep.
Okay. Now we just have to box it. That is 5 marks for you. Very
Pop up,
easy.
Devan.
Oh, sorry. Okay. Let's move on
And
to the
for
next.
those who want to, they can change a to the power of negative 1 to 1 over a. That is
Oh,
also fine.
okay. That's good to know. Okay. Sequences, new to the syllabus, new in 2020, right? We didn't have
Mm.
this back when we did additional maths.
Oh, yeah.
The first 5 terms of a sequence are given below: 4 minus 2, 1 minus 0.5, and 0.85. Find the 20th term of the sequence. Yeah, sure. Only give 5 seconds to have to find 20th. Sure. So what kind of sequence is this?
That is a geometric sequence
Why? Why is it a geometric sequence?
because we can see that each term gets smaller, but there's no added difference. It's you can divide each term by negative 2 and you'd get the next.
Exactly. So let's find the nth term for this to make things simpler. Remember that in geometric sequence, the general formula is a times r n minus 1, where a is the first number in the sequence, and r is our common ratio. So what's our common ratio here?
It is negative half.
Negative half. What about our first term? That's just 4, right?
Mm.
So we have 4 times negative 1 over 2 to the power of n minus 1. So let's just do a small check when n is equal to 1. When n is equal to 1, this just becomes 0, and we have 4, correct?
Mm.
When it's 2, we have power 1 instead. 4 times negative 1 over 2, which is just negative 2. Everything okay so far?
Mm-hmm.
Okay, it's good then. That means we just have to put 20 for our n. N is equal to 20, right?
Mm.
Okay. So 4 times negative 1 over 2, 20 minus 1. Can you put this in your calculator, Yugan?
Yeah, you get negative 1 over.
1 over.
It's quite a big number. 131,072.
Wait.
1 over
131.
072.
072. Okay. Is this our final answer?
Mm-hmm.
Okay, let's box it.
You can also change it to like standard form or something.
Oh, sure. What was
Give
it
me
in
a sec,
standard form?
Devan. That's just a way you can give your answer. In standard form, it's negative 7.629 times 10 to the negative 6.
Okay. Negative 69. All right. But any of them is fine, right?
Oh yeah, any of them is fine.
Okay. That's nice. Right, next question. Explain why the sum to infinity exists for the sequence and find the value of the sum. So, for a geometric sequence to have a sum to infinity means that the common ratio has to be between negative 1 and 1. Correct?
Mm-hmm.
And because our common ratio is negative half, that is between negative 1 and 1. So we write it as because negative half is between negative 1 and 1. Or you can write it like this.
Yeah.
Yep. So that's 1 mark. And find the value of the sum. So the formula to find the value of sum to infinity is s of infinity, sum to infinity basically, a over 1 minus r, where a is just the first term and r is the common ratio. So let's put that in. Our a is 4, 1 minus negative 1 over 2. Correct? That's our common ratio right there. And we have 4 over 1 minus is just 1 plus. 1 plus 1 over 2. That's 3 over 2. You can use calculator to solve this, to simplify this, but I can do this in my head. It's just 8 over 2.
Yeah.
And this is your final answer. Don't forget to box it. All right, next one. The 10th term of an arithmetic progression is 15 times the second term. The sum of the first 6 terms of the progression is 87. Find the common difference of the progression. Okay. So the 10th term, let's call it u of 10, is equal to 15 times the second term. The sum of the first 6 terms, so I'll put it here, S6 is 87. Find the common difference. All right. So for an arithmetic progression, our un, our nth term is basically a plus n minus 1 d, right?
Mm-hmm.
Okay. So if we were to have u of 10, that means it's just a plus 9d. For u, the second term, 15 times a plus d, because 2 minus 1 is just 1.
Mm-hmm.
Right. Now what about this one? What do you think, Yugan? How can you simplify this one?
So that sum would be, you have a sum formula, right? For an arithmetic progression. So you can just equate that to 87. That sum formula is, yeah, it should be here.
Oh yeah, here you go. So the sum formula is right here. I don't really memorize it though.
Oh yeah, it's quite long.
Yeah, I don't memorize it. But if you memorize it, that's good. But if you don't, you can just check the formula sheet again. So let's use that. So we have half n, which is just 6, right? I'm sorry, I don't remember the formula. So check it again. 2a plus n minus 1d.
Yeah.
2a plus n minus 1d. All right, so since our a, oh yeah, sorry.
Your n is 6.
Yep, our n is 6. That means we have 6 minus 1, which is 5. Okay, we equated to 87, correct?
Mm-hmm.
We can simplify this part a bit more. So we have 6 divided by 2 is just 3, right? Let's simplify this a bit more too. 3 times 2a is just 6a. It's just 6a.
You can divide 87 by 3 actually.
Oh,
You
really?
get 29.
Oh, okay. That's better. We have 29 here. Okay. So we're asked to find the common difference, which is d. How can we find it?
So you can substitute a. So yeah, looking at the first equation, that's easier. A. Oh no. Yeah, either one is fine.
I think we can simplify the first equation first, right?
Yeah. Simplify the first one and then we can substitute.
15a plus 15d, correct?
Mm-hmm.
Bring both of these to our side. We have 0 is equal to 14a plus 6d, correct?
Yeah.
So now we have two equations. We have 14a plus 6d is 0. We just have to do simultaneous equation then here. So what would you do?
You'd substitute a. So a would be negative 6d over 14.
A would be negative. A would be negative 6d over 14. Yeah.
And that would be negative 3d over 7.
Sorry?
Just to simplify, it's negative 3 over 7.
3d over 7. Okay.
And then you'd put that into your first equation.
So we have 2 of negative 3d over 7 plus 5d is 29, right?
Mm-hmm.
Let me just resize this. We don't have space. Sorry, you cannot do this in the real test though. So how can you find this?
So when you simplify, it'll be negative 6 over 7d. And then 5, you can change that to 35 over 7.
Okay. I think we can just... So 35 over 7d, 29. What's next?
All of that coincidentally is negative 29 over 7.
Over 7d, 29. Okay.
Yeah. So
that
now
means
you...
Yukan, hello?
Oh yeah, hello. You can cancel 29 and multiply by negative 7. You'd get d is negative 7.
Okay.
Pop up
This
Devan.
is our final answer? Oh, sorry.
Yeah.
Okay. So that's our answer. D is negative 7.
Wait.
Yes?
It should be 7.
It should be 7. Maybe I made a mistake. Perhaps I made a mistake. Because 35 minus 6 is just...
Oh wait, yeah, that's... Oh, okay, that's my bad.
It's okay. All right, next question. For this progression, the nth term is 6990. Find the value of n. Right. So that if you want to find the nth term, we have to find the a first, correct? Our first term, basically. So as you can see here from here, a is just negative 3d over 7. That means because we found our d, we can just put d in. Negative 3, 7 over 7. The 7 just cancels and we have negative 3. Therefore, our nth term is just negative 3 plus n minus 1 times 7. Is that correct? Now the nth term is 6990, so we have 6990 is equal to negative 3. We can expand this. We have 7n minus 7. Right, and we just have to bring these two constants to the other side, right?
Yeah.
Just solve this normally, basically. We have 7,000. Oh, it's a nice number. And just divide by 7, and it's equal to 1,000.
Yep.
All right. Very simple, right? 3 marks for that. Right. This is our last question, basically. Okay. The circles with centers C1 and C2 have equal radii of length r centimeters. The line C1, C2 is a radius of both circles. The two circles intersect at A and B. Given that the perimeter of the shaded region is 4 pi, find the value of r. I think I've seen someone ask this in the Discord server. They had trouble with this, but it's okay. We can do it. So let's stop and think. So the perimeter of the shaded region, this one right here, is just 4 pi. Because they're symmetric, that means this half part is just 2 pi, correct?
Yep.
All right. And the confusing is, how do we find r?
So
what would you do?
We can start by drawing a line between A and B to separate it into two parts.
A and B, like this?
Yep.
Okay.
And then we draw a straight line from C1 to A and C1 to B.
C1 to A and C1 to B.
And from there, we should have the area of the arc AC2B as 4 pi. Perimeter.
2 pi, right?
Oh, okay,
2
so
pi.
yeah, that's 2 pi.
2 pi for this one here. And now what?
So with that, S equals to r theta, yeah?
R theta, correct? So this R theta is the equation to find the length of the arc of a circle, correct? So what's next?
So now we don't know theta, but
we don't know
R. Yeah, and we don't know r, but we can try to find it because we know that you look at the triangle C1 to the intersection to A, you know that the halfway point between C1 to C2, because that's r, this should be half of r.
Half of
and C1 to its point A, because that's another point in the circle, is just r.
So right here, this is r, right? R. This one is r. Okay.
So we can find the angle AC1 to C2.
AC1.
That would be
C2. Okay.
Okay. So we have the hypotenuse and the adjacent. So we can use cos theta is the
cos theta. Where's theta, by the way?
It's the angle AC1 to C2.
Oh, so this is theta. Okay, so cos theta is just
the hypotenuse over the adjacent.
With hypotenuse, which is r, correct?
Yep.
All of divided by half r, which is
r's cancel. And you get 2.
2. Cos theta is equal to 2.
That is...
wait, sorry. No, it should be adjacent.
No, adjacent over hypotenuse.
Yeah.
That's... yeah, but the r still cancel.
Yep,
so we get half. And of course, that's just 60 degrees.
So when you do cos inverse, you get 60 degrees, right?
Mm.
60 degrees, or just pi over 3, up to you, or 60 degrees. Whatever you choose, whatever. It's okay.
Mm-hmm. You can also, instead of doubling the angle, you can notice that because the shape is symmetrical, the line A to C2 is just pi.
Mm-hmm.
So from that, your sector, the sector length is pi, and then equals to r times, and you have to use it in radians, yeah, because this formula is applicable in radians only, pi
Mm-hmm.
over 3.
Ah, I see. Okay. So from here, we we found that an angle is pi over 3, correct? But
Mhm.
we're looking for r. How can we find r here?
Yeah, so for that theta, its arc length is pi because we're dividing into 4 segments, and that's just pi.
So that means you're talking about this part, right? This is just pi.
Yep.
Okay. That means we have r times theta, which is pi over 3, is just pi, correct?
Mm.
So we just have to solve this, right? We just divide by
Yeah.
pi, multiply both sides by 3, we have r is equal to 3. Is this our answer?
Mm. Yep. That's it.
Okay. We just box it. Very simple for 4 marks. Find the exact area of the shaded region. Okay. You again?
Mm-hmm.
Oh, sorry about that. So
It's okay.
let's find the exact area of the shaded region. So as you can see here, uh, I'll have to separate the region into 2 parts. We can look at this as the sector.
Devan? I think he cut out.
Yeah, sorry, I kind of lagged out. So we can split this region. Let's talk about the top part first into 2 regions, right? The sector and the small part. Hello, Yugen?
Mm. Yeah. You cut
Oh,
out
okay.
for a bit.
Oh, sorry. Okay. So we split that into 2 parts. That means if we want to find the area of the shaded region, we just have to multiply by 2 of the sector added by that small region. Is that correct?
Mm.
Right. So let's do that. Let's find what that is. Let me just erase this. Okay. So let's find the sector first. 2 times the sector is. Remember the formula for finding the area of a sector. It's just half theta r squared. But this has to be in radians. So we have
Mm.
half pi over 3 r squared, which is just 3 squared, plus now for this one, this small area here, the way to find that is uh, we use the area of the sector again, but we have to minus by the area of the triangle here. Is that right, Yugen?
Yeah.
Okay, so let's do that. I'll put a bracket so it's not that confusing. We have half pi over 3 and 3 squared. So let me just draw it here again to make things clear. Sorry, bad
Pop
drawing.
up, Devan.
Oh, sorry. We, we want this part here.
Mm.
So this is pi over 3. And if you take a look and make a line here again, because both are r, that means this also has to be pi over 3, right?
Mm.
So so we can use that information. This is also pi over 3. This is an equilateral triangle, luckily. And that means the area of this, the area of this triangle is just half AB, using the half AB sine C formula. This is r and r. Put this down here. This is just r times r sine of pi over 3, correct?
Mm-hmm.
So the formula, another formula I use is this one, sine C. So that's half r squared. Sine pi over 3 is root 3
Root
over
of
2.
3 over 2. Mm. Devan?
R squared.
Mm.
So everything okay so far?
Yep.
All right. So when let's expand the 2 in, and we can cancel the 2 and the halves. This one becomes a 2 here. And let's add them together. We have pi over 3 and 3 squared plus pi over 3 squared, minus root 3 over 2. Oh, sorry, the r squared should be 3. 3 squared.
Mm.
3 squared. We can simplify. Can you simplify this, Yukan?
Yep. All the 3 squares would be 9.
9. So this is 3 pi plus 3 pi, 6 pi, right?
Mm.
Minus 9 root 3 over 2. Correct?
Yep.
Which is
And
our final
yeah,
answer.
they ask for exact. Yep. Then that'll be a
Alright.
final answer.
Alright, so that's box our answer, and we're done with the paper.
Mm-hmm.
So that's it for this
So,
episode. Hope that wasn't too bad. We made a few mistakes there.
mm-hmm. But yeah, that's something you guys can learn from as well. See that mistakes can be easily made by even the people of highest caliber. So
No, don't say that.
and and
Don't
that's
say
that
that.
for today. I hope all of you enjoyed this session and learned something valuable. And thank you, Devan, of course, for your time for
Thank you,
doing
Yugen.
this. And
We'll see you next time. We'll be okay. So we'll see you next time. Goodbye.